Hi, pre-cal honors. So this is note 6.1 and 6.2 day 3. So we are on day 3 of our remote learning. So today we're going to talk about this picture right here. But again, I want to remind you, when we think about vectors, we're going to think about the vector in component form, and we're going to think about its x and y components, or its horizontal and vertical components. So we're going to think about a vector as the hypotenuse of a right triangle. Okay, so if I have a box on an inclined plane, we have the force of gravity that pulls the box down, and then we're going to talk about its components. But again, I wouldn't say x and y or horizontal and vertical because we're on an incline, so that might be confusing. So AC, this component of the force of gravity, is the component of the force that, I'm sorry, here's AC, that is perpendicular to the incline, and it tends to hold the box against the surface of the ramp. And then there's a component over here that tends to push the box down the ramp. Okay, so we could also talk about angles. That we talked about this the other day. That if this is a right triangle, that if this is theta, we know that this is 90 minus theta. So let's just say theta is 40 degrees. This angle would be 50. And so that's how I know that this angle right here is 40. So a lot of times you might see an example, and right away a person just knows that this angle right here is theta. But that's how they got it. That's how they did it. Okay, so here we go, everyone. We're going to consider example number 2. It says a force of 30 pounds just keeps the box from sliding down the ramp inclined at 20 degrees. So here's our incline. Here's our box. And so if you have, let's talk about the force of gravity. Okay, so right now, looking at this picture, if we talk about the force of gravity as the hypotenuse of a right triangle, we've got the component of the force of gravity that is parallel to the incline, and that's the 30-pound force that just keeps the box from sliding down the incline. We have the force of gravity that's perpendicular to the incline. And so again, we know that this angle right here is 20, right? Because we could find that this angle is 70. Okay, so we have a right triangle. So using this right triangle, and we're talking about the force of gravity, which is the hypotenuse of the right triangle. All right, so we could say that the sine of 20 is opposite over hypotenuse. So we could find the force of gravity, which is the weight of the box, and it's 87.71 pounds. Let's do another example. Go ahead and turn the page. Now we're on page 9. So for this next example, number 3, there's an 1,800-pound car that's parked on a street. And the street makes an angle of 10 degrees. And so the force of gravity then is the weight of the car. It's 1,800 pounds. Okay, so we know that you could consider it, think of it as the hypotenuse of a right triangle, so consider its components. So we're talking about the component of the force of gravity that's parallel to the incline, and the component of the force of gravity that's perpendicular to the incline. So, and again, we have a lot of right triangles going on right here. We could say that this angle is 80. We know that this angle is 10. And now we know that we're trying to, for part A, we're trying to find the magnitude of force required to keep the car from rolling down the hill. Well, that would be the component of the force of gravity that's parallel to the incline. And then B, the force perpendicular to the street. That would be the component of the force that's perpendicular to the incline. So for part A, you could say the sine of 10 is A over 1,800. So that's 312.57 pounds of force. And for part B, you could say that the cosine of 10 is B over 1,800. So B is 1,772.65 pounds of force. Okay, let's do another example. Okay, go ahead and take a look at number 4. Number 4, it says a 50-pound force that makes an angle of 25 degrees with an inclined plane is pulling a box up the plane. The inclined plane makes an angle of 18 degrees with the horizontal. Okay, so I'll explain that one in the next video.